threats to deal with, including natural disasters like moonquakes and Marsquakes.
They're not active the way we're used to on Earth. They're active in different ways, and there may be unexpected ways that they could cause problems for us.
Since our current knowledge of these other worlds has literally only scratched the surface, it's possible that in the future we could locate a base right over a fault line without realizing what's below. And since weight is always an issue when carrying things into space, the lightweight buildings could be quite vulnerable, especially the outer layer.
If anything happens to that protective layer, that's trouble, very rapid trouble, as the gases stream out of the habitat. You've got to have a very efficient and quick procedure for getting into a spacesuit to survive that sort of decompression.
Death would not be instantaneous if oxygen and atmospheric pressure inside the colony are suddenly lost. On Mars, there is a thin atmosphere, although it's not breathable, since it's mostly carbon dioxide. On the Moon, there is only the vacuum of space. But you'd still have a chance, as we've learned from industrial accidents in vacuum chambers on Earth.
Exposure for maybe a minute or so is survivable. Now, if you stay in a vacuum long enough, there's not enough oxygen, so nitrogen that's saturated in your blood and your tissues comes out of solution and causes bubbles. That's decompression sickness. And also, if you hold your breath, you can get what they call pulmonary overinflation, and your lung ruptures into your bloodstream, and that's called an embolism. So there's multiple factors that can result in death from exposure to the vacuum of space.
Then there's the temperature extremes. Temperatures on the Moon go from a high of about 240 degrees Fahrenheit down to around 290 below. Mars can get just as cold. Although you could get lucky and have a nice 70-degree summer day. But without a breathable atmosphere, going outside without a spacesuit is still a very bad idea. Another thing above-ground space colonists will have to be on the lookout for is meteors. The craters on the Moon tell the story. It's an easy target.
We're relatively comfortable down here underneath these layers of protection. We've got a thick atmosphere which absorbs and burns up meteorites. We go to the Moon, nothing. There's no thick atmosphere. We are exposed to everything that space is throwing at us. We go to Mars, there's a thin atmosphere, but it's not anywhere near as good as the Earth's. Again, we're exposed to what's coming in from space.
Smaller meteors that are only inches or fractions of an inch wide, known as micrometeoroids, will strike most often and without warning.
You're walking along the surface of Mars, and something the size of a grain of sand comes slamming into your spacesuit. That's going to be a serious problem. It's going to be a loss of the pressure in the spacesuit. It could mean loss of life of an astronaut. When we have lots of people doing a lot of work on other worlds, eventually that's going to happen. That's the equivalent of a lightning strike, a rare, possibly fatal event.
Micrometeoroids could also punch a hole through the wall of a colony building. Like space stations, colonies will probably be built in a series of sections or modules. And just as crews have had to seal off sections of a space station in an emergency, colonists will likely do the same. Large meteors will hopefully be tracked, so the colonists will know they're coming. But evacuation might not do any good. A nearby strike would still send out a deadly shockwave for miles. A 10-foot-wide meteor hits with the explosive equivalent of 6,000 to 8,000 tons of TNT. Flying debris could also damage colony buildings beyond repair. And anything approaching a direct hit, there'll be little evidence that the colonists were ever there. It's unlikely that colonists would live anywhere near one of Mars's volcanoes. And the moon probably hasn't seen volcanic activity in the last few billion years. But even ancient remnants of volcanoes could still cause trouble for crews in vehicles.
Both the moon and Mars show evidence of volcanic flows. So we might expect to find there this sort of thing, volcanic caves. Now imagine driving along the surface, come across one of these, you're not expecting it. That could ruin your day, it could ruin your vehicle. You could be at the bottom of this pit without any way to get up. Even worse would be imagining one of these volcanic caves with a thin layer of volcanic rock on top of it. You move across on top of that, it gives, and down you go.
But not all colony disasters will be so dramatic. Simply running out of supplies is one of the greatest dangers. Since the moon is much closer, emergency supplies could arrive in a matter of days. With Mars, help is many months to years away, depending on how the planets are aligned.
On Mars, if something goes wrong and you lose some supplies, resupply from Earth can be 2 or 3 years away. You think you've got enough to last, you lose half of it through an accident, you're dead. It's a real problem. I think that means you're going to have more than what you need. You're going to have enough for 5, 6 years.
Living in space much closer to home, on space stations and longer shuttle flights, has already taught us a lot about the dangers of space. And fire is space crew enemy #1.
The reason fire is such a threat is because spacecraft traditionally have higher levels of oxygen than the atmosphere, certainly in higher concentrations under pressure. They're also filled with electronic equipment. Electronic equipment puts out heat, and often there are sparks and arcs. It's a bad combination.
Luckily, designers have made it easier for crews to put out fires where all of those miles of wire lurk behind the control panels.
This is a mock-up of the Space Shuttle flight deck that we use for training of crews. If you look at the various panels we have, you will see small holes like this at various locations around it. And these are for fire extinguishers, so that if there is a fire behind one of these panels, you can put an extinguisher in there to extinguish the fire.
Andrew Thomas knows a thing or two about fires in space. While on the Mir space station in 1998, a fire suddenly broke out.
All the smoke was pumped right out into the cabin.
Crews hurtled through space in their enclosed craft, desperate to maintain the Earth-like atmosphere inside. Out here, fire is one of the biggest threats. In 1998, NASA astronaut Andrew Thomas is on board the Mir space station with 2 Russian cosmonauts. Suddenly, a fire breaks out. Ironically, the fire starts while cleaning what's known as an air scrubber, one of the filters designed to remove exhaled carbon dioxide and other toxins from the space crew's environment.
All the smoke was pumped right out into the cabin, and so all of a sudden